Please retrieve AMD and NVIDIA financial information and write them to separate files. So the agent has these tools, as you can see, and
The
it has.
financial information for AMD and NVIDIA has been retrieved and saved to separate files. AMD financials.txt.
Okay, thank you. Stop right there. So it actually retrieved this NVIDIA and AMD financial information using the Get Company Financials, Yahoo Finance. We can also do more stuff because it is Perplexity Internet Search. Can you please compare AMD and NVIDIA by performing detailed internet search? Now it's calling Perplexity, as you just saw maybe. It just doesn't display when I mute my microphone.
Detailed comparison of AMD and NVIDIA. Financial performance. Net revenue.
Can you instead write it as a summary to a file? So now it's doing that. Here we go. Here's a comparison. Please make a search on who will provide the most GPUs for large language model training and answer it in a single sentence. It's again performing Perplexity search.
The majority provided by NVIDIA, with their A100H100 and RTX series being highly popular in the industry
Okay,
for their
thank you.
high
Stop right there.
performance and compatible. All right, if you need anything else, feel free to ask. Have a great day.
So it has quite a lot of tools, including calculate, get time. We can search archive. So we can do actually not just financial stuff, but scientific stuff too, by retrieving archive papers. Let's try that now. But before trying it, this is written in pure Python, by the way, as you can see, and with Fast API, very simple, just HTML and JavaScript. This took me quite a while. And the code files for this the source code is available at my Patreon. Link will be in the description. I also have a simpler version, the Python version that runs in the terminal. That's going to be also available at my Patreon too. And you can find that at my Patreon as well. But we will be overviewing the code. There's quite a lot of code. For example, here, this is just the Python code is 500 lines, but I will try to explain it as best as I can later in the video. Okay, can you please retrieve how to build an agentic system for large language models from arXiv?
Found an archive paper titled Retrieve, Generate, Evaluate.
Can you please save the title and the authors of this to a file?
Title and authors of the archive paper have been saved to
Can you
archive
please search for the first author on the internet?
Yuhnila is a postdoctoral researcher in biomedical natural language processing, NLP, at ETLF, affiliated with the CNRS and the University of Lorraine in Nancy, France. She specializes in biomedical NLP, clinical tech. You're welcome. If you have any more questions, feel free to ask. Have a
So it is quite open-ended, especially having internet search Perplexity. It can call these it can call each tool multiple times, as a matter of fact. So it's a open-ended agent, really, a real-time action-taking agent. So now let's actually review the code and try to explain it. But actually, before that, let me show you the terminal version as well. So this one runs in the terminal. Let's run it quickly. It's going to start right here. We select our input and outputs. Hi there.
Hey there. How's it going?
Can you find out the latest NVIDIA stock price from Perplexity?
The latest stock price for NVIDIA Corporation, NVDA, is $132.89.
Okay, thank you.
You're welcome. If you need anything.
So it is the same tools. I actually have a simpler version with just a simple dummy tool that is much less line of code, and I have one without tools. So maybe this will be the one we'll review, as this is the most important part. But before we begin reviewing, I do want to say that the example code that OpenAI has provided I actually grabbed the API client, conversation, and event handler JS, and I gave these as examples when building this. It still wasn't easy. It took me 5 or 6 hours to figure it out entirely. But just so you know, you can actually use these as it has example JavaScript code and how to handle all of these things, such as the function calls. Okay, now let's start by reviewing the code, but you can, if you're enjoying my videos, you can always find more videos of mine at my website, echohive.live, and watch them for free, over 300 of them. There's a search box if you want to actually find the content you're looking for. And if you're a patron, you can actually download any one of the source code to my projects, such as the knowledge graphs, structured data from long PDFs. Just click on the download code. It'll take you to my Patreon, and source code will be attached to each one of the projects, the posts. You can also check out my 1000x masterclass, in which I try to teach Cursor over 23 chapters. So it's very useful. I highly recommend it. So now let's get back to our code. Let's start with the real-time voice without any tools. Let me zoom in. So we do import quite a lot of libraries, async.io, base64 to encode and decode data, WebSockets. We are using WebSockets for communication. Although I did do a LiveKit video, if you can find that at my channel, which uses WebRTC, which is actually faster. We use SoundDevice for audio input and output, and threading for threaded base parallelism. Here we have a class to handle audio output, which is going to initialize audio parameters and start the audio output stream. So I don't pretend to understand exactly how all these work, but we'll scroll through it anyway, so you can pause and look. Audio callback function for the audio output stream. We're going to read the bytes, read data from buffer, and write the output with threading.lock. Not enough data, we pad it with zeros. Here we have the playback loop, continuous loop to process audio chunks from the queue, because there's quite a lot of chunks that you receive and send back and forth. You have to process those. Add audio chunks to the playback queue and clear the audio playback queue and buffer. These are all methods of this class. And stop and close the audio output stream. This is necessary when the user interrupts, for example. Class to handle main audio streaming functionality. Initialize the audio streamer with API key and device IDs. We do get the input and output device IDs, the URL, call OpenAI's real-time preview model, and sample rates and chunk duration that is set to the recommended OpenAI recommendations. And we call the API key. Make sure to insert that. And then we have a WebSocket connection. Connect to the WebSocket. Wait for session creation confirmation. And then we configure the session parameters. As you can see, we are using WebSocket, which we have defined up here somewhere. Yeah, AWS. And then we can receive and actually send real-time connection information. Start task for receiving events and playing audio. We start these as an async tasks. Main loop for sending audio. While through, we're going to be sending the audio unless there's interruption. Handle graceful shutdown on keyboard interrupt. Also, here is the send audio function to send audio data to API. This gets an event loop and is a callback function for audio input. And then set up and start the audio input stream. So as you can see, this is quite complex. Receive events function to receive process events from the API. Okay, so we check each event type. There's almost like 30 or more event types. I actually have the real-time API docs here as well. These describe each event type. I'll include that in the source code as well. So we try to handle as many event types as needed. Handle incoming audio data, for example, which comes in deltas, streaming, and it can be done, for example, handle the end of audio and print response complete. Handle start of user speech, and then there's also input audio buffer speech stop, handle end of user speech, handle error events. So we're trying to take quite a lot, like when the user is talking, ending, and we are using the server side voice activity detection. Select audio device. This is just a function to query the devices and print, as we've seen in the beginning. Main function is set up and start the audio streamer, get the API key, set up the input and output, initialize the class, and run it. So this is the simple version. Now let's go to the one with tools. So let's try to find the places where it deals with the tools. So if we have a tool registrar class, it's going to initialize a dictionary with tools. We have a method to register a tool, to get a tool, and get tool definitions. We are getting the tool definitions dynamically using the inspect module. If we actually go back up, yeah, we are going to import it later in the function, the code. We also have some attributes such as should record and stuff set, which we can keep track of certain things, which we can use to keep track. So here is the register tool. We call this the register tool. Print register tools. Here is the start. So when we are configuring the session parameters here, as you can see, we're passing the tools there. And with the type turn detection type is server, voice activity detection. Pass the tools and we set the tool choice to auto. And when we are receiving events in the receive events method, as you can see, we were checking the different event types. Here we are also checking event type response function call arguments delta, and then response function call arguments done. So here, this is where we handle the function calls with the handle function call method. Just going to get a call ID, the arguments, and the function name. And then this is where we register. I'm sorry, we get the get tool from registry, and then we execute the call with the tool, and we send back the results with the WebSocket. But with the type of function call output, call ID, and output, and we handle the exceptions. So that's what the changes are in a nutshell. Example tools here was just get better and get time and calculate. And essentially, when we're running the main function, we register these tools, and then we print the register tools and run it, and everything else should be handled automatically. In the case of additional functions, we just define our functions, and the outputs always should be string, by the way. That's something to keep in mind. And when we are registering the tools, we do have to register them separately. So you do have to manually modify these lines. So as far as, so in the case of the Fast API app, it's essentially exactly the same. As you can see, we're registering, except our JavaScript is doing quite a lot of logic here as well, like such as update conversation history, update tool list, connect to the WebSockets. Because now in the case of the Fast API, we are using two WebSockets, right? One in the main.py to connect to the OpenAI API, and one from JavaScript to connect to the backend. Okay. And that's handling the WebSocket connection, and disconnect button here actually will disconnect from the API as well. Toggle mute button, start audio stream, stop audio stream, play audio, create visualizer, which we see right here, the bar visualizer, update the visualizer. So that's about it. And index.html is just where we place all the elements. And style.css has just some styling, but we also are using Daisy UI. So this is it. I hope you enjoyed this. This took me quite a while to build, but it works well. I'll try to improve it as well because it has some quirks. When you handle so many incoming and outgoing WebSocket messages, things can get quite hairy. But for the most part, it works well, and you can download it from my Patreon. And I really, again, would like to mention my 1000x masterclass because I've spent over 3,000 hours building with Cursor, and I wanted to share my knowledge. Currently, there's 23 app building walkthrough videos with their source codes as well. I just have to update the course description. The first chapter is free, you can watch, and it has chapters such as how to build full stack apps, how to build multimodal RAG system, how to build a Grok chatbot. And most of the time, we are using natural language and Cursor to build with. Each one of these is an entire building of an app from start to finish, such as how to build a universal chat. And the latest videos are actually how to build an O1 Oracle, which performs long-range research or long-form research using Perplexity on any given topic. For example, this is an hour and a half long. Very interesting stuff. I'd recommend it. And if you'd like to get in touch with me one-on-one, I have tiers on my Patreon in which you can do that. I have helped many of my past patrons with their projects with that. So consider that as well. Other than that, take care and thank you for watching.